you a timeline about the history of the thing. Okay? First, in 2010, I wrote there. In 2010 was our first competition of first leveling. First is an acronym for inspiration and recognition of science and technology. It's a competition about you go to a regional, then if you win, you go to a national, and if you win, finally, you go to an international competition of level. It's with you create a robot. In 2011, in the competition, we built a machine which name is Frutalizador, which conserves the fruits for longer time. With this project, we won the national, and we went to Legoland, California in 2012 to the international. In the same year, we participate in the competition of Brainers Awards, which is a competition for young inventors. In 2013, we participate now with other project, which name is Robotix Junior App. This app helps the old person, the old people, to have a better lifestyle. And this is our new project, Jetmars. Now, my partner Hector continues. Now.
The topic of the things that we needed to do was first build a robot. The robot must be able to pick up things, heavy things. The robot must be able to travel long distances, for about 500 feet, and it has to be larger, about 2 feet by 2 feet. And this is what we do. First, we design the robot. Then we build it with Lego pieces and test. When we test, we realize that the Lego pieces won't be able to carry heavy things. So we change to aluminum pieces. Then we design the robot and build the robot, but we start with aluminum pieces. When we test by putting a heavy object over it, we saw that in relation to the robotic car, first we design a type of robotic car, and we test, but we saw that the robotic car was very little, so we redesigned, rebuilt, but this time larger, and we add a degree of freedom, because before it was only up, down, open, and close. So we add the movement of right and left. Now my partner Rafa is going to explain the technical.
A robot is called Hubble and Cube. Here you can see the construction. It's more or less 2 feet by 2 feet. It weighs almost 13 kilograms, and it's made of aluminum pieces and Lego pieces. Okay, the motherboard. Here you can see there's 2 motherboards here and other 2 here. What that does is you connect this one to this one, and this joystick makes the gloves move, and this one connects with this one and makes the motor move. The robot go forward, backwards, left, right. The software we use is called LabVIEW. We didn't use the software that came with the motherboard because it is not compatible with the DC motor or the servo motor. At first, what we used was a USB connection, but then we changed it to Bluetooth. Description of the motors. There's 2 types of motors. DC motors and servo motors. The servo motor, what it does is it tells you the exact position it is on, but it is not designed to carry weight. So what we used was the DC motor, which is designed to carry lots of weight, but it is not exact. The position of the motors. Here you can see in the cloud that there's one servo motor here, another one here, and there's a DC motor here. There's 4 servo motors, one here, another one here, another one here, and here. And there's another DC motor here. We also use 4 DC motors, one on each leg, to make it move forward, backwards, left, or right. The degrees of freedom. It has 3 degrees of freedom per each robotic arm. It's left, right, up and down, and open and close the claw. So there's 6 in total. And on the chassis, there is forward and backwards on the rocker boogie. On each one, so there's 2, and on this one there's forwards and backwards too. Here you can see it. Okay, the development. Here you can see the robot again. Everything we did about the robot and about everything, we first, what we did was brainstorm. So the best ideas got chosen. After we had brainstorm, what we did was to build it, make it real. And after that, we program it. At first, we used a wire, and but then we changed to Bluetooth 2.0 because it's easier. You don't have to go with the wire behind it. The live streaming and the activities. In the page there were some activities that we were supposed to do and some live streams that we were supposed to see. One of the live streams, what they said was Poppy Face. It was an activity in which you are supposed to lay down on the floor with your legs 90 degrees up. What that does is it makes your blood go to your upper thorax and your head. That's basically what happens in space. As there is no gravity that's pulling your blood down to your head, to your legs, it stays on your upper thorax and your head. We also did something called astronomical units. Everything we do is always measured. It also happens in space. Astronomical units are units that help us know, for example, how much time or space is behind, from the Earth to Jupiter, or from the Earth to the Sun, or different places in space. Here you can see that we were measuring how much time it will take to go from Earth to Jupiter, and it's almost 5 years. We also did an activity called Mars Bound. What Mars Bound does is that Mars Bound was an activity in which at the start you have $250,000 million, and with that you have to design a trip to go and investigate the planet Mars. Here you can see the things that we chose. We had to choose a rocket, an Oscorn, the power system we were going to use, the computer system, the communications, if we were going to use a rover or not, and if we were going to use it, the entry, descent and landing, also the mechanical systems and the science instruments. After we had finished doing all this, what we did was shuffle some green cards, as you can see here, and we took some. And those green cards are case scenarios of what can happen in real life. Okay, after we had finished doing a session, because we had 3 sessions each per week, what we did was post everything on our Facebook page, so people could know what we were doing, and how to do it. Here you can see a comment from someone called Infinite Space Dynamics. what they wanted to do is kind of give us advice on how to make better this robot, because they saw what we were doing because we posted on Facebook and they contact us. Okay, okay. Now, my friend, Hector, we continue with what we learned. No, I'm sorry.
Results.
Yeah, sorry.
Test and results. When we test the rocker boom, we realized that the robot falls. So we put little parts in this part to support to the robot and fall. Then first the robotic arm. When we test the robotic arm, we realized that this part couldn't carry heavy objects, so we changed to a DC motor because of its power. And the result was that the arm can carry, I think, a heavy thing. Then the communications. First, we control the robot by a USB cable, but we realized that there isn't any cable so larger to go to Mars. So we changed to a Bluetooth wire. And when we test, we saw that the robot had more freedom in the movements. And my partner is going to explain the part of the videos.
Now I will show you some videos about the progress and steps of the robot. Well, what we saw here is that in step 1, the robot has only one back support, and doesn't have a claw, and only have 2 DC motors in the front. Step 2. Well, in this video, we saw that the robot has now a limit for the rocker boogie, well, to don't stop. Well, and the problem here, with the type of wheels, we use Omni wheels in all the robot. So the robot, it's very unstable. So we change it by all rubber wheels, that type of wheels on all. Step 3.